Hello, and in this tutorial I'll show you how to get Blynk to work with the ESP32. The ESP32 is a low-cost microcontroller similar to the Arduino and a successor to the ESP8266. Blynk is a powerful mobile app available on Android and iOS. It can be used to interact and communicate with your ESP or Arduino-based devices. Examples of where such systems may be useful include monitoring temperature and humidity of your plants, or monitoring the power level generated from the sun or the battery level connected to a series of solar panels. Blynk is effectively free of charge, so all this can be done for relatively low cost. So let's get started. So the ESP32 is not naively supported by the Arduino IDE. So first connect it via the USB cable, and then we need to install the drivers for the board. Searching Google for ESP32 Arduino leads us to the GitHub page for this board. From there we can follow the installation instructions. Which essentially leads us to a link which we need to copy and then place within the preferences within the Arduino IDE. Without this, you will not be able to find the ESP32 within the board's manager. Now navigating to the board's manager within the tools option, we should be able to search for the ESP32. Once found, install. Once the installation is complete, the ESP32 and other boards should now appear under the list. You can follow a similar process as described here to install other boards such as the ESP8266. For this particular board, for which I will place a link in the description below, use the ESP32 Dev Module option. Next we need to install the Blynk mobile app on your phone. This is available from the Google Play Store. Once installed, we can begin creating our first app. So start by selecting New Project. From here we can give it a name, a color scheme, and we can select the type of device we're going to communicate with. So in this example, we're going to create a basic temperature sensor. And we'll be using the ESP32 dev board. The connection type will be Wi-Fi. Once the app is complete, an authentication token will be emailed to your registered address. This authentication token is essentially an address to the device. Now we can begin to customize our app with widgets. You can use a certain number of widgets for free. If you require further widgets or more advanced widgets, you have to pay. In this example, we'll be using the simple labeled value widget. So we'll begin by adding one of those. In here, you need to give the widget a name. An associated pin number. And in this example, we'll be using virtual pins 4 and 5. And you can also associate it with units. So in this case, degrees Celsius. The interval at which the parameter is read can also be specified, or in this case we can use push, so that every time a new value is updated, it pushes it to the application. We'll complete our app by adding a second labeled value for the humidity, which we'll associate with virtual pin 5. The authentication token can be retrieved from the settings menu and copied to the clipboard or re-emailed to your address. Once retrieved, you'll need to copy this as we'll be using it later within the Arduino code. The Arduino code has essentially been generated using the automatic code generator available from Blynk. It's been modified slightly for this project, and a link will be available in the comments below. You can use the Blynk code generator to generate your own projects using a variety of compatible boards. In this example, we use the ESP32 with the Wi-Fi connection, just as we did within the app. The Arduino code needs to be modified for your specific Wi-Fi connection as well as your authentication token for your device. Do this by finding the relevant sections within the Arduino IDE and replacing them with your own details. Other parameters such as pin numbers should be left at this stage. Once updated, you may save the Arduino code and attempt to compile. The project requires several libraries which must be installed if they've not been done so already, so if there is problems compiling, this is most likely the reason why. Libraries may be installed using the library manager available under the Sketch option. The 3 libraries required for this project are the DHT sensor library, the Blynk library, and finally the Adafruit Unified Sensor library. You should now be able to successfully compile your code and upload to the ESP32. This can take a while, so be patient at this stage. Once uploaded, you can test the code by using the serial monitor to check successful connection to Wi-Fi as well as to the Blynk servers. It's finally time to connect our temperature and humidity sensor to our device. For this tutorial, I'll be using the DHT11 sensor, which has 3 pins: S for signal, minus for ground, and a sensor voltage pin. These sensors are widely available and are incredibly cheap. I'll put a link to where you can buy one of these in the description below. Connect the red voltage pin to the V-in pin on the ESP. Connect the black ground pin to ground. Finally, connect the white signal cable to digital pin 13. All that's left is to power the ESP using the micro USB cable. Returning to the Blynk app within our mobile device, we should now see that the ESP32 has connected. By clicking the play button in the top right hand corner, our application should update with values obtained from the sensor. Once connected, we can test the sensor by covering it with our fingers and watching as the temperature rises. And that's it. Like me, you can now successfully monitor the temperature in your greenhouse and save your legs from having to walk to the shed to check out the state of your solar battery. If you found this video useful, please don't forget to subscribe and check out the website kabu.com for more tutorials. Thanks for watching.